Welcome, good afternoon everybody. You are in the tutorial on Python debugging. Why might this tutorial be interesting to you? Now imagine you've been doing Python data science for quite a while using Jupyter notebooks and your program grows bigger and bigger and bigger. Or you want to take your data science pipeline from a prototype stage into production. Then eventually you might have to debug your program in a different way instead of just writing line by line. And this is where debugging actually becomes important. When your program grows, when you want to add more quality to it, make some extra checks. And in this tutorial we are going to exercise a few of the most common debugging techniques in Python. I would like to invite you to an obstacle course to prepare this. I wrote a program, a short piece of data analysis, and then I broke it. I started building bugs into my own program. And we are going to find and fix these bugs together. Now, I put a link for the entire material here. You also find it on GitHub, but without some of the bigger data files. So if you want to try the full thing, then please take the bit.ly link. Also, at the end of this tutorial, I'm going to toss out a couple of books. Okay, let's go. Now, what is the question that we are going to deal with over the next 1.5 hours? The goal I want to tackle is this one. The question, are monkeys and bananas genetically similar? I'm a biochemist by education. I've spent, I think, a decade analyzing biological data. So these kind of things are around the corner for me. What does it mean? How are we going to do this? Imagine the following. We are looking at protein sequences. Protein sequences are basically character strings, and we want to count the characters and then compare which characters are the most frequent ones in monkeys, which characters are the most frequent ones in bananas. And for reference, I also included human data so that we have a matter to compare that. And there is in the downloadable material, there is a Python script that does that. And your task is to go to this code. It's in the folder code buggy. The program's name is parse uniprot. Try to run it in Python. And then we are going to try to fix all the bugs that we find. I will accompany that here in the front for those that don't have a laptop on their knees or didn't fit it in the room anymore. Let's try. No. And when you run the code, what you should see is something like this, a syntax error. Everybody of us has been there, probably on their first day, trying to program Python. Syntax error, the most common error. What can we do about such a thing, an exception? Any suggestions? How to fix a Python syntax error? What we do to find the solution? We are looking here for techniques for debugging. How to get there? Sorry, is? We can use MDB? NDB. What else? First look at the source code. Which part of the source code would you like to see? It starts with the very easy things, right? So syntax error are the most obvious errors that we can have, or the ones that are the easiest to find. So it starts with technique number 1. We first read the error message, then we read the source code at the according location. And what we see there is the reason for the syntax error should be pretty obvious to everybody. Okay, so what's the problem here? Missing colon, thank you. There we are. Now we can save the code and run the program again. Another one. Now we are done with the syntax errors. The program starts executing itself, and we get a runtime exception. Again, we can try to identify the source of the error by reading the error message. So I'll take your suggestion that we had a couple of minutes ago and read the code at line 55, the side of the error message. Where is it? Line 55. I get a file not found error. This is the one of the other most frequent bugs. I think this is the most frequent exception I've seen in my life as a scientist and as a Python programmer as well, and it comes in all sorts of flavors. What's the problem here? Did anyone find it already? The file is not present in the output folder. Exactly, so should I, how could I fix that?
Where is parsing?
So we have to look a bit into different places. It's called here at the very bottom. It's a little bit more difficult because this line is not self-sufficiently pointing us to the error. We are actually trying to write a file here. Yeah? So this is the output file. We are creating a file, so we have to open it in writing mode. This can be already very difficult to find if you are not familiar with the code yourself. If this has been written by someone else, or you have written this a long time ago. Now, I would like to point out one interesting thing about these exceptions in Python. If we read the error message, then the most obvious things are the syntax errors. These are if something very obvious is wrong. And syntax errors, they prevent your program from starting altogether, so no code gets executed. The second exception that we had already was of a different kind. Our program is the building and it starts burning while we are using it. So we have to differentiate these two a bit from each other. Why? With the syntax error, normally you find the error at the site where that is given in the error message. With an exception, this is not necessarily so. Why am I saying this? In my opinion, bugs in Python are not always easy to find. In particular, the error messages are not always that helpful. Consider this example. I hope it's big enough for you to read. Obvious error, we forgot the closing bracket. Okay, Python complains. Now, compare what happens if we forget the bracket on the other side. We get a different error message, and none of these two error messages is, hey, I was looking for a bracket and did not find it. It's a very different experience or a very different kind of message than those you get from a C or Java compiler. Yeah? So these Python error messages, they have to be taken with a grain of salt. Please don't treat them as a gold standard. Sometimes they mean something different than you see. Anyway, in this case, we have found the issue. Now, what happens if we run our code once again? Everything's fine. At least it seems. We can check the output folder, and the one that I've created is sample.csv. You shouldn't have these other three on your machines. Now, at this point, we might stop debugging. Or can we? We should have a look. We definitely should have a look at the data file. What I see is this piece of explanation. What would we expect to see here? First, we would expect to see all the counts of the different characters from our input file. But what we see instead is a long list of zeros. The other thing that we don't see is all the entries that originate from our input file. If we look at the input file, there should be a couple of hundred different of these string sequences. So this repeats, and the program should generate one line of output for each of those. But there is only one, and it's empty. Yeah? So now we have a third kind of error. The program seems to work. Python does not complain, but it does not do its job. Yeah? And at this point, debugging really starts. Yeah? So we have to dive into the program now and see what is it actually doing. We have no error messages that could help us anymore. Now, at this point, I would like to introduce one of the most popular debugging techniques in Python. You all know it. What could we do to diagnose what our program is doing? Print. Print is quite a nasty debugging technique. It works most of the time. It's not elegant. Yeah? It's a little bit like shooting holes into a building to see whether there is a fire inside. This is my own image for print, for debugging, but somehow it works 90% of the cases. Now, where could we actually start printing something here? Great, let's add a print to line 61. What should I print? Yeah, I'll print everything that comes out of the for loop for a start. Okay, so it looks as if our input file is at least read more or less correctly. We arrive at the point where the print statement is reached and where it gets data. More than one entry, obviously. Yeah. There is more than one entry appearing on the screen pointing us to the fact that the data is actually there. This is an important piece of information that we did not have before. Okay, so we know up to this point things seem to be okay. Now, if we get stuck at this point, we could add a lot of print and mass print statements and print everything at every possible point in our program. And when you do this, you will start realizing why I think print is not the ideal solution for every debugging problem. Because if we print everything everywhere, we will mess up our entire program. Second, we will have to remove the print statements afterwards. And third, we are generating so much output that it might be difficult to see what we are actually looking for. Time for debugging technique number 3. I used to refer to this as the scientific method. This is not an invention on my own. I heard this from Andreas Zeller, whom I consider an authority on debugging software. And what it comes down is something that you as data scientists should be familiar with, and that is we make hypotheses about our program and make a prediction, not using machine learning this time, using our own mind, what might be the reason for the thing we see. Does anyone have a hypothesis about what could be a reason that the program is not doing what it should? Yeah. The header parsing seems to fail. Okay, something in the header parsing seems to be wrong. And now with this hypothesis, we could start to make predictions and then prove them. Does anyone have a different hypothesis? Because there's still more than one bug to find in this one. Yeah. So the hypothesis, your hypothesis is that the AA that's encoded as a string might be wrong. Let's stick with this one because it's closer to the issue at hand. So the hypothesis is that AA is a string, whereas it should be a variable in line 67. And the prediction is for that because of that, we don't see anything in the output. Or we could predict that because of that, we are not counting the amino acids properly. Well, this is something that we can check. Now let's add another print statement. And see whether they are in fact empty. And it seems that your hypothesis is absolutely valid. We are not counting anything at the moment, but the occurrence of a lowercase AA, which we don't have because all our input data consists of capital letters. And with that, we have a fix at hand. We remove the quotes. We might keep the print statements inside for the time being. Much better, isn't it? Now, is anyone here in the room who had to make a hypothesis while debugging before? In what situations does this technique prove useful? When you know the expected results, when you have some reproducible way of checking whether your program executes correctly, which may involve manually checking their output file, like we do it here. You could do a an automated test there, which is not our topic today, okay? But it's kind of round the corner. Also, what I sometimes do is I write down the issues that I'm seeing. Some people write these as GitHub tickets. Yeah. I sometimes use a notepad for problems that I cannot solve within the first few minutes. Because when you keep staring at a bug and keep staring at it for 15 minutes, 20 minutes, all the time that is left until midnight or whenever your stuff needs to be deployed, then it gets hard to remember after some time what actually was the issue that you started with. So this is an important point about this technique number 3, is to keep some kind of notes that describe what the problem actually is. Okay, looks much better. I could remove the prints now, simply because I don't like to see them in my code. Now, of course, I don't see anything anymore. And I can look at the output. Hooray, the numbers are there. Still, something is missing. We only get one entry in the output file. Now, imagine you've been debugging for a couple of hours, and you get to the point where you get stuck on this kind of bug. Yeah? And at that, when you get there, I would like to recommend you one more debugging technique that has not much to do with computers, it has to do with humans. And that is talk to someone. Talk to someone. I've heard, or maybe it's a programmer's myth, maybe some people are really doing this. That's explaining the problem to someone. Some programmers are said to use a rubber duck for that. And they say, if you can explain the problem to a rubber duck, then maybe this already helps you by verbalizing this, that you come to a solution earlier. So we are stuck with the problem that we see only one output entry. So try the rubber duck technique. I prefer to talk to people actually instead of ducks. Yeah? Please turn to each other for 1-2 minutes, reason or try to explain each other what the problem is, what might be the possible reasons. If you have found a solution already, then think about what other problems might there be around the corner. Talk to each other. Dino. Of course. Okay. Okay, listen up, please. I know this is a very fruitful exercise to talk to. Ducks are not very responsive. People are usually. It's fun to do, and you may have sudden insights. Did you have any insights about the problem at hand here? Yeah, You did. What's the problem here? We can indent the row here. This is a very common thing that Python is prone to produce, especially if you migrate from other programming languages or you're still in the beginner stage where you need to realize that indentation has a semantic meaning, and in this case, yeah, we are stepping out of the loop too early. So we need to step inside and indent this by, I think it is by one level of indentation. Please correct me if I'm wrong here. This should do it. Now, let's see whether that helped. Whoa, whoa, whoa. I see lots of output suddenly. Now, I step back into the program. Did you have any other insights while talking? Any other things that might deserve fixing or improving maybe? I was interrupting you too early probably. Whether you ask me personally, yeah, that's actually a great question. No, actually, I'm very unhappy about the format of the output. Personally, I think it is very obscure. Yeah? It's hard to see what the data actually is about. Yeah? Why is that so? Does anyone else have this problem that the output is not very easy to read? This looks like machine readable, but it definitely does not look human readable. Yeah. What's the main reason why it's hard to read? Sorry, it's every entry is one line. It's not so bad basically, but the font size is too big. Yeah, it comes. You know, that's a trade-off when you do trainings with 60 people. Then you have to take a bigger font size. But I take your point.
There are commas in the wrong places, where it's not very clear if the comma separates two different
Oh wow!
for one number.
I even wasn't aware of that. Really, you just found an issue with this code that I hadn't found before. Yeah. So there are commas in the description. If we again read this into pandas, then this will fly into our face. Yeah. Actually, all this string-like stuff there at the beginning, the annotation that tells us what kind of protein is this. Well, basically, if we just want to count things, then for the time being, we don't need this. We have a unique identifier for that. The accession number, I think it's here, it's these numbers that look a bit like old school secret keys, yeah, in the middle. These are the ones that we would like to have in the output. And we can get rid of all the rest. And this is a great kind of thing that you find out while talking about your code with another person. So when we create the output here, then I would like to get rid of the sequence name that is there in order to make the output shorter, easier to read, have it everything in one line that maybe even here fits on the screen width. And now the issue comes back that you mentioned earlier about that we have some other issue regarding the parsing. But let's see first what we see here. We still have lots of text in the output, even though that is because the name and the accession are swapped here during the parsing. This part here. Some of you may have found it already. Yeah. So we can simply exchange the order. Fine? Fine. this is an unused piece of code. It's dead code. Happens when you write program. It's like on a construction site when you heavily work there. Then after some time you have parts lying around, and this is something. What we are now doing is we are using something that is not directly a debugging technique, but it definitely helps with debugging. We are cleaning up. So we are both cleaning up our code, we are cleaning up our output file. I'll get rid of the fragment. It's not good for anything. Okay? Saves us one line, and it saves us nerves later, maybe. Well-chosen font size, maybe. Yeah. So now we are getting there. This is the kind of thing we would like to have as input for a Panda script. Before we continue to read the code into a table and start evaluating this, there's another thing I would like to try. That's debugging technique number 6. I would like to try a simple assertion here. Python software engineers, they argue from time to time whether putting asserts in a program is a good idea or not. Yeah, I don't have a final opinion on that, but for this kind of debugging, making sure our data is consistent actually pays off. I would like you to try the following. I want to have an assertion here that checks whether the length we are putting into the file is actually the same as the sum of the characters we are counting. Should be obvious. If we put a sequence of a given length inside, then we would expect to count as many things as there are characters in the string. Could be. But when we run this, we get an assertion error. So this assertion does not hold for at least one of the strings in our data set. Now, how can we? So this is good for making sure the data is consistent, but it doesn't. So it helps us to discover whether there is a problem. So how do we find the issue? At this point, we are ready to use some of the heavier machinery. I'm not going to start looking for the source of this assertion problem with print. We could do that. I think the program still has a small enough size for this, but instead we are going to use the interactive debugger. What do we have? Number 7. It's PDB. Some people claim IPDB is even better, but the differences are small. If you don't have IPDB installed, you can use PDB and everything is fine. Now, when we start using it, going into an interactive debugging session, the thing that I usually do is I call the debugger from my code. I could call the debugger from the command line as well, but I'll do it like this. No, I know this is not like you write Python every day. This is one of the few situations where I find it justified to put more than one Python command into one line. Okay, if you think this is still too ugly, make it 2, it doesn't matter. And when we start the code, then we get into a debugging prompt that starts with PDB. Who of you has been in the interactive debugger before? quite a few. Okay, great. So we have a couple of commands that are available here. Which do we have? What could we do now? Sorry? We can step through the code, but I don't know where in the code we are. L. So if I type L, I see a portion of the program plus a small arrow that tells me where we are at this very moment, which the arrow points to the line that would be executed next. And now we can step through the program. We can execute our code in slow motion. Yeah, this is great. It's like doing the same thing you are used from Jupyter Notebook, but on a smaller scale, stepping through all the cycles of a for loop if you want to. It's a great tool for debugging. It's really tiny machinery that we are using here. Okay, how do we step? Which is the command for that? I put it in the slides. You have it on GitHub, but maybe anyone from the audience remembers. How could we execute the next line? Sorry? No, continue just starts running our program normally. N for next. So here, this executes the next line, brings us to the next, and we can execute our program one by one. After some time, it pays off to press L again, and we can then see where we are. N has a cousin that is S, which I will not use right now, because what would happen then is we get to execute the function that we are calling at the moment, in this case, the parse header function, and continue our interactive session there until we are done. Oh, now I did it. Great. So I'll just step through the lines one by one. I hope there is no loop here. This is how interactive debugging sometimes looks like, until we reach the return statement, and at which point we get back to our original program from where we left. So this is the S command. It steps into a function and starts interactively debugging this. Now, how is PDB useful for diagnostics? We have here a lot of the normal things available that we can do on the Python console. That means we can inspect variables, we can use introspection functions, we can change, we can modify values of variables. So, for instance, if I'm at this point here, then I could check what the length actually is. It's 156. Great. I could check what the type of my length is. I could use functions like dir, where I can see what does my namespace consist of. Which variables do I have? I could use a function like locals that gives me all the local variables and their content. Now this was maybe a bit fast. What I typed was this function, which I don't find too useful in other contexts, but in an interactive debugging session, it's great. Now, we found out about the length, and now we reached the for loop. What I would like to see, to trace the source of our bug, is to actually compare manually the length that we calculate with the count list that we calculate. Now, the problem when we reach the for loop is that our program, upon executing these lines iteratively by the next command, is that we have to go through this cycle many times. Yeah? And this is very annoying. This is very annoying. I don't want to do this manually. So what I do here is I will set a breakpoint. A breakpoint means I want to have a point in the program where it runs to, and then as soon as it reaches the breakpoint, it stops. I'll place a breakpoint with the B command in line 68. So the debugger tells me you've created a breakpoint at line 68, and now I can use this C command for continue, which tells me continue the program until it either ends or you reach a breakpoint. So this will complete the entire for loop for us. So what have we seen? We have seen quite a couple of debugging commands here: L, N, S, B, and C. There's another one you may find useful, that's Q, for quit. If we see we cannot save our session anymore, we want to get out of it and start again, then Q is the right one to press. Now, let's see what we found. We have the length by now, and we have a count. It's a counts. And we could now check the assertion manually by checking some AA counts and see, whoa, it's a different number. We have a length of 156, but we calculate 153 in total. Has anyone figured out how we could find out what the problem is? Or what else could we look at here at this point? The input data might be wrong, so let's look at the input data. But we derive the length from the input data, so we calculate the length of a string, and the string is this one. We have to strip it. So we see, okay, there are new lines that messed up the data where we are doing the counting. So at this point, I have enough information. I know what the problem is. I'll get out of the debugging session and back to the program and see, okay, where did I forget to strip something? It's here. Yes. Sorry, could you repeat the question, please? Yes. You can do that. So if we are inside the debugger, let's get inside again. And we have some local variables here, for instance, the length. And I want to see whether the program would execute correctly with a different length now. So I could say length should be now 156. You can do that. Okay, now I would be changing it from the correct to the wrong value because 153 works right already. Yeah. So, but yes, you could do all the editing. You have access to all the Python functions here. We could replace the new lines here inside the debugger. Now let's continue, and again we have an assertion error. So what does this assertion error tell us? It's still the same issue, but we thought we fixed it already. Now we fixed it for one of the entries. There might be other bugs for other input data. The problem is how to find those wrong entries. Okay, so let's say you are used to working with big data sets. Let's say you have 10,000 entries in your input file, and entry 9,700 is somehow false and causes a problem with, would cause this kind of assertion error. What you definitely cannot do is to go into the interactive debugging session and say, hey, I manually will skip the first 9,699 entries, and then finally, after a couple of hours, I will be at the one that is eventually wrong. We could use print statements, which is not ideal either. Here, I'm going to use another feature of the interactive debugger, which are conditional breakpoints. Conditional breakpoints consist of, you set them by typing a B, then a line number. You could also use the name of a function and a Python conditional expression. We can use the same conditional expression here as we did in our assertion. Now let's check. I go into the interactive debugger. I say, I want to have a conditional breakpoint right before the assertion. I need to know the line number for that. So I check my code, search for the assertion, and I would like to have a breakpoint here at line 69, because I know until then everything should be fine because it fails only in line 71. So I say breakpoint at line 69 with the condition length is not equal to the sum of my list of counts. Okay? This means, this is very flexible, so this breakpoint will only stop if the condition applies. So it means it will skip all the correct entries and stop at the one that we know will fail the assertion. So, and now I can press continue and wait and see where the interactive debugger actually is going to stop. Now we are here, no surprise, at the breakpoint. It's marked by the small b on the left side. And we can check what data did we actually get. And I look at my input string. Does anyone spot a potential issue? No, the quotes are there because it's a string. There's no space inside. Now, this is a nasty one. There's no X. Are you a biologist? You either have to look what actually are we parsing there, what characters are we counting, or you have to have the expert knowledge that tells you immediately, oh, there's an X, this means missing data. This is the corresponding thing to an NaN. And we see, okay, wow, the X is not among the characters that we are counting in the first place. Sometimes you find those things if you are a biologist, you will notice this immediately. If you are a data scientist with an expert knowledge in some other domain, this might go unnoticed for quite a while. Yeah? And this is why I'm happy about that I'm having this assertion in the code to reinforce my code against this X slipping through. So we have, of course, to decide to have some strategy against this kind of missing data, because there's more than one X in the data set. Yeah. In this case, I know enough already, and I'm going to fix the thing on the parser side simply by replacing all X's by nothing. You can think of a smarter way to resolve the issue, and maybe there's even better solutions.
What happens if there's a line?
So if there's...
The line has
wi- if there was a Y. Okay, if there's this amino acid alphabet consists of 20 characters. Right, an O, for instance. O is not included, B is not included. Then, yeah, then we would have to maybe make a regular expression out of this. I'll check whether this works, because I think there are no O's and B's in my code. Oh, I still have the call to the interactive debugger here. Now I just press continue, and I mistyped the syntax in my hotfix here. And now it runs. All the assertions have passed. Yeah, this is the point where I'm really happy about the result, and here I have some reliability about the result actually being correct. Did anyone find any other issue with the code? There's one more bug inside that is very difficult to find with our sample data file. The Homo sapiens spelling. This Homo sapiens spelling actually is being messed with. There is a bug here in line 49, very good. It's the name is converted to lowercase, and then something in mixed upper and lowercase is being searched there. But we just removed working with the name, so this is actually dead code. We might as well throw it away. You got another one.
Yeah, in the output file, the header, we removed the name, and it is still in the first column name.
I think.
When I look at the output file, I have 3 columns for the...
Oh, it's still in the header, so we should make this nice, otherwise pandas will have column labels messed up, so we need to remove the name here. Excellent. What else could we do? Any other issues? Yeah, I think I removed this already some time ago. Oh no, I didn't. Okay, we might skip this entire function parse header, except the part that gives us the accession number. This would actually simplify the code, make it easier to maintain. Yeah, this goes a bit into the topic of refactoring, which I don't want to dive into today. Yeah, but yes, this is something that we might do. One issue that is hard to find, and for this, we need again to look at our input data. Something we might have started with, but you came up with very smart debugging suggestions quite early. Our sample input file consists of, I think, 1,000 lines. This is not a very convenient size for debugging. Actually, I would prefer to have a smaller input file. In fact, I would like to have an input file that is as small as possible. So I get to my input data again. And I would like to extract just 2 entries here. And I create a new file, and then I make the input even shorter. I make one sequence, I name it Python, and I skip most of the crap from the header, and the other sequence is just data. And I call this mini.fasta. So why am I doing this? What do you think? Exactly. what I'm now doing is manual unit testing. I could easily automate a test like this. I could calculate the correct result with my fingers. Yeah, my kids could calculate the correct result from this. They can do this. They could not do this with the full sample fast-R file because the numbers get too big. Yeah, and the outcome should be kind of obvious. So, which means I need to run the sample, swap the sample for my mini input file. I run the code again, and at this point I probably could remove the debugging statement. What went wrong now? Yes, I did this by putting the conditional breakpoint right before the assert statement. There's more alternatives to that. Yeah? I could, for instance, run the code from IPython, and then I could do a post-mortem analysis. That means the program crashes with the assertion error, and I can examine the last frame that Python was executing. I could look at all the variables. They don't just disappear. They are still there. But it's post-mortem. It's called post-mortem. The name is not a coincidence. It's like examining a dead body, yeah? Because you cannot execute anything anymore. We cannot rewind the program execution by one frame. So the problem here, of course, that there is no O in protein, so I have to take a Q in Python here. So now let's see how this works. And I want to see the output for my minimal input file. And what I see is this. So I see an output that I now can easily check manually. So the first entry was Python. Python has 6 characters, and now I could match the columns. The last one is a Y, seems to work. Which one is the next to the front? 1, 2, 3, 4, 5, 6, 7. That's the H. So, and I can check, are there 6 ones in the entry? Great, works. But now, at this point, I should have discovered that there is a bug in the code that we did not figure out before. What's the problem here? We had a second entry. It's missing. Where has it gone? Has anyone found the place in the code already? We could now go through the entire cycle of diagnosing this program step by step again. But this is something that is very easily forgotten when you write file parsers. If you have some custom file format and you need to parse it, then this tends to happen over and over again. If I look at my generator function that generates pairs of header and sequence with the yield statement there in the middle. This is basically a question for those who are more familiar with generator functions. And we process our entries one by one, somewhere in the middle, yield them, but we will also need a second yield here in the middle. At the end of the function. Yeah. This is the one that was lacking, that produces us the very last line, the very last entry from the data we read. So, okay. So what happens? We start reading the file, interpret some data. The thing is that yield always gives back one pair of header and the string. To do that, it needs to know that the entry is complete, that we have collected all the lines containing text data. And in order to do that, and how the function recognizes that is by seeing that the next entry is starting. That's the if at the top. If line dot starts with greater than. This is the signal, okay, the next entry has started. We need to first to yield the old one before we can start parsing the next. And this way you miss out the last one because there is no starting signal for the next entry. And this is why this yield is necessary here. This string-based format, it's a classic that is used by computational biologists around the world, and parsing this kind of file format is a very good exercise that, I don't know, probably hundreds of thousands of people have done already, and it's good to try this because you stumble upon these kinds of issues there over and over. Okay. Now, with this, we have covered quite a few different debugging techniques. Before, I would like to switch to introduce the last one that I have prepared here. I would like to ask you, are there other debugging techniques that are worth mentioning at this point? What else could we do to make our program better, make it more correct?
One quick one that I sometimes use is if I get a lot of dirty inputs, I'll just ignore faulty things and count them, and if it's just a few, I'll just go on with my work. It's not like the program level, but it's like getting the shit done.
So it's like simply going through and driving through the mud and seeing whether you get to the end of the road and then eventually take care of the dirty things later.
And I count how bad it is.
Okay. Yeah. So how should I put this on the board? Okay, try except. I would like to. Can I summarize your strategy? That works with try except. Okay, try except. Count how many entries you lost. I find this a very viable strategy because Pandas is actually quite good at dealing with missing or dirty data. You can actually still do your plots even if half of your data set consists of NaNs. Great, thank you. What else can we do? Tests. So tests pay off very greatly when you know you will have to maintain your code over a longer time. If you are just doing prototyping and you know your code is going to change rapidly, there is not really a point in writing tests because then you will have to change twice as much code when your code is changing. But if you know, I want this to be stable, I want this to be reliable, I want to have parts that I can combine, great. This is something that I would consider for this read faster function, yeah, to write unit tests for this. Or I could write pip install biopython and then use the already existing parser for that. Would save me a couple of lines, but then all of you would have to install that. Any other strategies? You got one. So a linter. Is anyone using a linter here? That's PyLint or PyFlakes? Yeah. What does it, brief summary, what does it give you for everybody who doesn't? So the linter points out syntax errors, things that might be potential errors, style issues.
Yeah, for example, the unused variables we found earlier, the linter already found that for me because I take the line and linter.
So unused variables are a potential source of errors. Variables that you initialize twice are a potential source of errors. So there's quite a lot of things that the linter is quite useful to prevent bugs from happening. The good news for you is if you are using Anaconda or if you are using PyCharm, then you probably have one of those linters already built in, so all the PEP8 issues, they get highlighted by some underlining. If you are using Sublime, there's a plugin for linters, and I heavily recommend you to use them.
What's better to use, the text editor or the ID?
If I start answering these questions, then we'll be brawling here in the room, I think.
The context of debugging.
In the which I think it really depends on what tool you are used to. So I prefer to do debugging from the command line because this is what I grew up with. Okay. Some people, they run their code from within Sublime. Others, they start the code from Anaconda, where you can do the same things as with PDB, but you have buttons for that. Yeah. Also great if you like that. Putting in breakpoints in your code is very convenient in PyCharm and Anaconda. Yeah. But I'm a little bit reluctant to give a general recommendation on editors. When I learned programming, once my mentor was trying to convince me to use Emacs. He tried for 4 years, and he was not successful. Otherwise, this would be a Lisp tutorial. Yeah. So the linter, PyLint. Flakes. You got another one?
Yeah, so mine is very Jupyter specific.
Yes?
I always restart the kernel, and that's the source of many errors because there is things in the memory.
That's a good one. I've seen that happening in Anaconda 2 quite a lot. That is, if you run your program, it still uses the variables that are left over from the previous one. And in Jupyter, of course, this will happen as well.
It's the same with Docker sometimes. We got some cached stuff.
Really? Docker does cache stuff?
Like not cached, but sometimes you start your Docker container and have some kind of flashes sitting there because maybe you exit in the container and it's changed something.
Can I add container here? Yes.
Some of your Docker compose services.
Mm-hmm. Yeah. One thing we are not covering here is all kinds of bisection strategies. That is, imagine you have some huge data set, and you know that some part, somewhere in the data set, there is a data error, some kind of inconsistency, but it's not as easy as in our case to find out where it is. So what you can do then is to partition your data set, test both parts independently, see is it in the left slice, is it in the right slice, then partition the one again until after a log n number of iterations you find one line or a few lines that are the source of the problem. You got one more.
One more thing would be like you also include file numbers in an error message. So you use enumerate and count file numbers and you have a big file. If you use the line number, that can be very useful. You use a C step. There might be some line in the file, and if you say one of the 100,000 lines is bad, it's not very good to say it's line 90,000.
I'll come to that. I still need to write up the one that I mentioned previously. That was the bisection strategy. There's a very sophisticated procedure that is called delta debugging. It's in the same GitHub repository as this tutorial, which mainly allows you to identify if there's 2 lines in your input that create a problem only if they are together. Then delta debugging is an automated procedure that allows you to locate this. It's a cool one, but it's very sophisticated, and I only found very few use cases for that. So this is why I did not put this here. So regarding your suggestion about outputting line numbers, this goes a little bit into the direction that I would like to mention or allow us to try out at the end of this tutorial, and that is logging. I have an example for logging. Why do I mention logging here in this tutorial? It's because when your program grows bigger, let's say above a couple of hundred lines, above 1,000 lines of code, you won't get very far with print anymore. When print becomes something between annoying and completely useless because it does more harm than good. What you will need then is logging, and this is my final debugging technique here. Yes. So what I mean by logging is that we write our program in such a way that it produces some meta information that accompany the output. So in addition to our primary output file, we generate some second file that allows us to see what the program was doing. So where the program tells in a little bit more words what actually did happen. So like, I read entry number 1, I processed entry number 1, then I read entry number 2, then I read entry number 2, then I wrote an output line for entry number 2. In entry number 3, I found something dirty, so I skipped it, and so on. And the thing is that I would like to show you here is that logging in Python is super easy to use. Yeah? You can build a lot of things on top of logging. You can use a dedicated logging server. You can build a search engine on your logs if they get huge. I'm not even poking into that. Okay? You can use other log formats than text files. Fine, try it. But the most basic thing for the average data science pipeline is that you collect useful information in a second file that you might want to look at later. And how does this work? There is a built-in module in Python that is called logging. And we need to initialize this, which basically means we say, hey, all our log should go into this file, debug.log. And we set the logging level to warning. This will need a bit of explanation in a second. And then when we have set up this, we can, from anywhere in our program, including different modules, we can use a couple of functions like logging.info, logging.debug that result in a string being written to the log. I can try this. The program executes and I end up with 2 messages in my log that consist of 3 pieces of information. On the right, there is the string that I actually sent to the logging module. Here, for instance, factorial calculation ended. This is what I created here at the very bottom of the script. Then, before that, there is root, which is the identity of the logger. Root is the default. It has nothing I'm not running my scripts as a super user. Yeah? And if you want, you can define multiple loggers and give them different names. I didn't care about this. And the first one is the seriousity of the logging level. And this is what I specify here at the beginning. I say, I want only everything that is a warning or more serious. And of these logging levels, there are 5 in total. The most serious ones are critical messages. Then there come errors, warnings, debug, and info. If you set your logging level to info, you will see everything in your log. Yeah? We can try that. If we change this in our program, if we write info here, then all the log messages like info and debug will also be written to the log. So our log file becomes longer by changing a single variable. This is what we get. Yeah? So by toggling a little switch somewhere, we can determine how much useful information our program is going to produce. Yeah? And if you are building a pipeline, this is one of the nice things that you can build in. Questions regarding logging? You got one. Mm-hmm. So why is there no timestamp given? Because you have to configure the logger to give a timestamp. I have some more typical examples of using the logging module here. And the second one has a template string with the date format where you actually put in a timestamp. But I commented this out. Yeah? So you have to switch this timestamp on explicitly. It's there. Other questions regarding logging? Okay. Then I'll come to summarize this tutorial in a moment and give you some extra hints. But first of all, I need to do something with you. I brought a pile of small cards. I hope you have pens with you. Some of these, they are a little bit wet because we had a bit of rain 2 days ago. Since there are quite a few of you here, I would like to ask you to make to cut them into 2 smaller pieces or rip them into 2 smaller pieces. Write your name into these because I brought a few copies of my book, which I would like to hand out to 3 lucky winners here at the end of the tutorial. So we need to pass these around. Write your name on a piece of card, and we are going to draw 3 winners at the end. So could you pass these around? If we run out of cards, then please please take some other piece of paper. It will be, I'll close my eyes. Okay. So, okay, what do we need to remember about debugging? So, first of all, debugging is not a random activity. Yeah? It's not something that comes by itself if you look at your code hard enough. Number 1. Second, debugging in Python is not necessarily easy. There are many places where bugs can hide. And this has to do with Python being a dynamically typed language. So when you write C or Java code, then your compiler will catch quite a lot of bugs for you, in particular type errors. Oh, I think I lost number 8 as well. Does anyone remember what we had here? Sorry? Minimizing input, thank you. Thank you for the question.
But I was wondering, for number 8, is it to minimize the input to let the code run through? Or is it also rather a technique to minimize the output, so that should be just print one line?
Both actually. In a sense,
so that your code runs through, but in production it won't run because you didn't take all kinds of data into consideration?
this is why when you test your program, you need to do both. You need to test your some minimal input to see whether the general mechanics are in place, whether something important got lost. And you also need to test it with a bigger input file to see whether it actually performs on a bigger output. Regarding this this monkey data, there is it. There is a script in the folder, in the Git repository, that actually contains a few more small bugs. You can actually take this and try out whether you find out whether monkeys and bananas are genetically more similar to each other than humans.
Yeah, I just wanted to add one more thing to the left-hand list there. That I think is quite important and maybe not so important for the data stuff, but generally super important is fuzzing. So especially when you run you write a program that interacts with inputs that you don't control, then fuzzing is a technique where you send just arbitrary data to that endpoint and see how it behaves. And it's a way to make programs more secure and it's better.
There is a dedicated Python library for that. I think it's called Hypothesis. I haven't used it myself, but it's a library that takes your data or takes some certain rules and generates random data. And it's been described as a very effective technique to find bugs that otherwise would have been lost. Thank you. Okay, so this is more or less an overview of how you can debug code in Python. So I've written a couple of chapters on debugging. Some of these end up in tutorials like this or on my blog. I'll be around for questions after the tutorial. When I'll finish the tutorial in a moment and then draw the lucky winners before everybody gets out, could we collect the code, the name snippets in some kind of device? Does anyone have a small bag? Oh wait, I got a Django Girls bag. Let's take this one. Could you pass this through or collect all the ballots so that we can draw some?
Is this also a step list? Like first do this, then second try to...
I was trying to think about in which order to proceed, but it really depends a bit on what is your programming workflow. In some projects, I would advocate before doing anything of this, do some test-driven development, write a test first before you even think about debugging. In others, you can take the bugs and deal with them as they appear. Yeah. Sometimes I never get to the stage where I have to start the interactive debugger. In other code examples, I don't seem to get out of this here at all. Yeah? So consider this as a kind of toolbox that helps you to make your Python code more reliable and get to a working state easier. There's a last thing that I would like to mention that is also an important debugging technique, and that is number 10 here. Debugging is a tiresome activity. Some people claim it's twice as hard as programming, which is why a valid debugging technique is taking a break. Which is what we hopefully will do right after the ballots are complete. Oh, we are done. Oh, okay. Doesn't matter. I'll pick them from the ground. I pick one from the bag. One from the ground. No. Let's get them inside.
Here you go.
Let's see whether anyone wrote Guido van Rossum. Okay, we got one lucky winner here. Peli. That's you. Okay, congratulations. Second edition of Python Best Practice goes to Talayi. Whoa! And number 3 goes to Alex Klink. That's it for today. It was a pleasure for me to be here at PyData and enjoy the rest of the evening. See you at the lightning talks. Thank you.